So composites, this is another nice section because it's really short. There's not really, well, actually, there are a lot of composites, but the ones you need to know for GCSE is very slim. Now, the definition of a composite is very different to an alloy. An alloy, for example, is two or more metals joined, like bonded together to make a new material. A composite is two or more different materials bonded together to create a new material which has like optimal properties or perfect properties for its application. Let's have a look at some examples. Carbon fiber is probably one of the best known composites and probably one of the most widely used composites as well. When I think of carbon fiber, I think of really high performance applications where strength is paramount, stiffness is paramount, but lightness is also crucial. So this is why carbon fiber is such a like wonder material, because it has this amazing ability to be incredibly hard, incredibly durable, incredibly non-reactive, very strong, and its stiffness is incredible. Like it can hardly flex or bend. So that this is why it's so good for like crazy high performance applications. So you can see here like I find I mean I've never been on one of these, but they look awesome, like these Oracle hydrofoil yachts. Now these are crazy pieces of engineering. Like this, like the Formula One of sailing, but these have a complete carbon fiber hull, and the foil on the bottom there is also carbon fiber. Now you think about with this kind of application, the amount of tensile strength that carbon fiber needs to have so that it can withstand and maintain its stiffness and not fail when the yacht has the force of the wind blowing across the boat plus the weight of the crew members, and all that force is being transferred to these little hydrofoils here. And so all that force and that bending is being pushed against the fin that's in the water. So you can imagine just how strong these really slender, like slivers of material, just have to be. And another one here, this video is actually really interesting to watch. This is McLaren making one of their, was basically showing how they build the chassis for their supercars. And it's interesting because they create what's called a monocoque frame, which is basically building the entire chassis from a single piece. So there's no joins or anything. It's just one single piece of carbon fiber. And that's another advantage of carbon fiber, is because it's basically sheets of carbon woven together, which is then bonded with resin, like epoxy resin. The epoxy resin makes it set hard. So you get the best of both worlds. Epoxy resin by itself is very hard, but it's also quite brittle. Whereas carbon fiber by itself is very, very well. It comes rolled up in sheets like you would like you get any other textile. So it's very flexible, but it has an insanely high level of tensile strength. So when you put those two properties together, you get this material that's really hard, and it's got an insanely high level of tensile strength as well. So it's almost like a perfect material for high performance applications. The only downside is it's very, very slow to manufacture parts from carbon fiber. That's why you don't get it on regular consumer cars. I mean, yeah, it would just be absurdly expensive, because it not only do you have to lay up, you do what's called laying up. You have to make a mold. You have to lay up the carbon fiber, the resin, and the carbon fiber matting. But once you've done the laying up, you then have to pressurize it, and then you have to bake it in an oven for a certain length of time and let it cure. And yeah, it takes a long time. And also another reason why it's terrible for any kind of regular everyday applications is because it's really hard to repair. So for McLaren, if you crashed a McLaren, not even badly, if you crashed it like sort of fairly, not like really badly, but it was enough to cause, say, dents on a regular car, what happens is carbon fiber doesn't dent. It will just bend. It will very slightly bend, and then it'll suddenly snap and crack. So when that happens, you have to have the entire segment of that piece of car replaced. If it's the chassis, that could end up having like fundamental cracks, like fractures all over the chassis. So the whole thing would have to be scrapped, and then you'd have to get a new one. So it's terrible for recycling because you can't separate the materials, and it's terrible for repairability. Yeah. So that's just something to bear in mind with carbon fiber. Another one is concrete and what's called rebar. Like concrete by itself, you can see in this GIF here, is really brittle. If you just have a literally just a billet of concrete like that with nothing inside, it doesn't take a huge amount of concentrated force to push down and suddenly it'll snap. You can see the hairline fracture building there and it suddenly goes. Whereas if you actually form concrete or pour concrete, as they say, around what we call a rebar structure, which is just literally just um, rods of iron that have been woven into a lattice. It's actually very similar to carbon fiber. You get the best of both worlds. You get the tensile strength and the flexibility of the iron, coupled with the extreme hardness and the excellent bonding of the concrete. So you end up getting this like super kind of super material that's strong, like in every way. It's ultra hard, it's ultra tough, and it has an excellent level of tensile strength as well. So yeah, GRP is very similar to carbon fiber, but instead of using carbon fibers, it uses glass fibers instead. Commonly, it's also called like fiberglass. And this is kind of how boat hulls are made. So if you watch the video here, it's very, very similar there. And that, guys, that's basically it. The important thing to know with composites are generally they're bad for the environment because they can't be separated into their constituent materials. It's a chemical reaction which actually bonds them together, or it's literally melting them, then they set around the other material. Number two is the repairability is very low. And number three, they're okay, concrete, sort of. They're quite expensive because it takes so long to manufacture them, and so they're not suitable for mass production, really. So they're only good for like batch or one-off production. Yeah, that's basically it.